All right, we're going to talk about average rate of change. So first we're going to talk about or remind you about slope of a line, which slope of a line is just rise over run. It is how much the line rises as it runs. Slope of a line. Average rate of change is what we're going to talk about in this lesson, which goes right along with slope. The average rate of change, which is sometimes abbreviated as Aroc, is the measure of how much the function changed per unit on average over that interval. All right, so we're going to look at how much it changes. Average rate of change is essentially the same as finding slope. Couple differences here. A linear function makes a line, so the slope will be constant. What that means is no matter what 2 points you're looking at, no matter what your interval is, your slope is going to be the same for that entire line. Whether you look at an interval going from x being 0 to x being 5, or you're looking at an interval from x being 0 to x being 25, the slope will be the same. If you reduce your fraction and simplify your answer, your slope will be the same, no matter how wide or small of an interval you're looking at. However, all other polynomial functions and non-polynomial functions don't make a line. They do not make a line. They make other graphs. So their rate of change, or their average rate of change, will not be constant. So in other functions, if you look at the interval from 0 to 5, you will have an average rate of change, but it will be different than the average rate of change for the interval of 0 to 25. So the average rate of change does depend on your interval if you're doing average rate of change versus slope. Because slope is for a line, average rate of change is not a line. The slope formula. So rise over run is how you can calculate slope from a graph, but if you have 2 points or if you have a table, your slope formula was y2 minus y1, all divided by x2 minus x1. All right, hopefully that looks familiar. The average rate of change formula. It's pretty much the same thing. You're going to take f of b minus f of a, all divided by b minus a, where a and b are x values. So you're going to find f of a, which is a y value. You're going to find f of b, which is a y value. So you're going to take these two y values and subtract them, and these two x values and subtract them, which looks just like this formula right here, right? Just like with slope, average rate of change can be found from a graph, a function, or a table. I'll show you how to do all of those. Average rate of change. If it is positive, it means your function is increasing. And if it's negative, it means it's decreasing. But no, this is on average over that interval. So with slope, if it was positive, that means it is increasing the entire time. But with average rate of change, if it's positive, it could increase and decrease. But if you have some graph like this, and I want to look at the interval from whatever this value is to this value there, it's increasing more than it is decreasing. So it's going to have a positive average rate of change. The average rate of change being positive does not mean your graph is increasing the entire time. It just means it's mostly increasing on average. So you don't know what's happening in between there. It could increase and decrease several times. Maybe I'm looking at this graph, and I want to look from here to here. And visually, I can see that this is going to be a positive average rate of change. Because if I look at this point and draw a straight line to the other one, that line increases. So on average, from this point to this point, my function is increasing on average. If it was going down from one point to the other, if it was going in a downward direction, then it would be decreasing. If it's negative, be decreasing on average over your interval. Does not mean it's increasing or decreasing all the time, just on average. All right, so finding first from a table. So these are going to be x values. This is an interval. Remember, we've talked about interval notation. So these closed off brackets means those are the ones we want to look at from -2 until 0. We don't need to look at anything in between there. We just need to look at from -2 to 0. So we need to take the y value at -2, which is 4, minus the y value at 0, which is 0, and divide it by the x value that we started with, which was -2, minus our second x value, which is 0. So that's 4 minus 0 is 4, -2 minus 0 is -2, 4 divided by -2 is -2. If you recall when you did slope in Algebra 1, slope has to be a fraction or an integer. It cannot be a decimal. So same thing here. If you get a decimal, we're going to turn that into a fraction. And remember, your calculators can do that. I will remind you how to do that if you forget. So our average rate of change from -2 to 0 is -2. Is it increasing or decreasing over that interval? On average, it is decreasing. How do we know? Our slope, our average rate of change is negative. All right, what about our average rate of change from 1 to 3? So at 1, my y value is 1, minus at 3, my y value is 9. And then I take my first x value minus my second x value. Now, does it matter? No, as long as you put everything in the correct order once you have it started. So I started with my x value of 1, but I also could have started at 3, which is 9, minus 1. Oops, this one. And then I would have divided by 3 minus 1. So you could start at 1, and if you start at the x value being 1, your y value, like you have to have, this has to be a coordinate point, this has to be a coordinate point. So if I started with 9, then in the bottom I have to start with 3. All right, so in the numerator here, 1 minus 9 is going to give you a negative, and 1 minus 3 in the denominator is going to give you a negative, and 2 negatives are going to give you a positive. Or here, 9 minus 1 is positive 8, and 3 minus 1 is positive 2. 2 positives give me a positive. So it doesn't matter which one you put first, as long as what you put first in the numerator goes with what you put first in the denominator, right? And then 8 divided by 2 is 4. The average rate of change is 4. And so what does that mean? It says on average, it is increasing. So it does not mean it is increasing that entire time. Maybe it is. But it also means, all it means is it is definitely increasing more than it is decreasing. All right, for a graph. So it does give you the function here if you want to use it, but we could just use the graph. The graph, you need to identify your interval, 0, 4. So 0 is here, and 4 is here. And you can absolutely count rise over run. You need to pay attention to how your graph is counting. These are counting by ones, and these are counting by ones, so just count rise over run. If these were counting by something else, you need to count by how these are counting. If these were counting by 2s, you would count 2, 4, 6, 8 as you rise. Right? So pay attention to how those are counting. But in this case, I'm going up 1, 2. So I rise 2, and then I run 1, 2, 3, 4. I went up and right, which is 2 positives. And 2 over 4 is 1 over 2 is your average rate of change. You also could have written them as coordinate points and then used your average rate of change formula. So that was 0, 0. And then this is 4, 2. So you would do 2 minus 0. If I put 2 first, I'm going to put 4 minus 0, which is 2 over 4, which takes me back to what I had. Personal choice, doesn't matter. Up to you. All right. The next one, or the next 2 examples, you have this function. And I want to find the average rate of change and then determine if it's increasing or decreasing over that interval. So you have a couple of options. These are x values that you could plug into your function. So I would plug -1 into all my x's, see what I get for my y value, and then do the same thing plugging in 2 and see what I get for my y value. And then use your average rate of change formula. Absolutely no reason why you cannot do that. make sure you would do negative 1 to the fourth plus negative 1 to the third plus 5 times negative 1 minus 7. See what you get. And then plugging in 2 to the fourth plus 2 to the third plus 5 times 2 minus 7. See what you get. And then take those and subtract, and then divide it by those and subtract. You also can use your calculator. Typing in your y equals x to the fourth, drop out of your exponent, plus x to the third, drop out of your exponent, plus 5x minus 7. And this time, I don't want to go to graph. I want to go to this table. And I have x values of negative 1, which has a y value of negative 12. And 2, which has a y value of 27. So you could type those in, and hopefully, if you do your math right, you get negative 12 and 27, and then that leads you to here. So feel free to do the extra work, and take the extra time to do that if you want to. Or, less time, more correct. Because here, you can make a mistake. And here, it's not very likely you make a mistake. So then, you take your y values, and I'm going to do 27 minus negative 12. Has to be a minus sign. And then my other y value is a negative 12. So make sure you have two negatives there. And if I have 27 first, I need 2 first minus negative 1. Once again, you have to have your two negatives. So then you can do 27 minus negative 12, which is 39. And it's 27 plus 12. And 2 plus 1 is 3. And then 39 divided by 3, if you didn't know, it was 13. It is 13. And if you didn't know, you just type in 39 divided by 3 and you get 13. You also could do alpha y equals and type it in as a fraction. Because if it didn't come out to be 13, it would then give you an answer as a fraction. So same thing back here. If you didn't know that 2/4 was 1/2, you could type in 2/4 as a fraction. Alpha y equals, hit the first one, 2/4. And then it will reduce it to a fraction for you. All right. As opposed to if you did 2 divided by 4, you now get a decimal, which yes, 0.5 is easy to turn into 1/2, but what if it was 0.8372? Do you know what that is as a fraction? Because I don't. So if you just type it in as a fraction, it's easier to do that. All right, last one. Once again, we have a function, so feel free to just, type your, oh, wait, stop, come back. Increasing or decreasing over the interval on average. If I could spell average. On average, it's increasing. How do I know? My average rate of change is positive. All right, now back to the last example. I can type my function in. So back to y equals, delete what you had. It is negative 2x to the third. Make sure you drop out of your exponent, plus 5x squared, plus 10. You can go to table, which is second graph. I want 2, which is 214, and 5, which is 5, negative 115. So then you can set up your average rate of change formula. I'm going to start with 14 minus negative 115. If I put 14 first, I have to put 2 first. I chose 14 because I like this to then be able to be 14 plus 115. I don't care what you choose, but whichever one you choose, you have to put the correct thing first in the denominator. So if you put 14 first, you have to put 2 first. If you would have chose negative 115, you would have to put 5 first in your denominator. So 14 plus 115, 129. And 2 minus 5 is negative 3. And 129, let's put this in as fraction, 129 over negative 3. Is just negative 43. So that is your average rate of change. Oh. And what does that tell you? On On average, it is decreasing since that is a negative average rate of change.